physical mechanism which gives rise to free particles trying to occupy the maximum possible volume. The drift mechanism is a movement caused by an electric field. This electric field makes the positive charge carriers move in one direction and the negative charge carriers in the other. If there is an electric field in a region of space, there will be an electric potential associated with it. The electric field points in the direction in which the electric potential decreases. The varying electric potential acts as a barrier, preventing the charge movement. Its effects can be understood with the following analogy. Let us consider a body moving at a certain speed in the gravitational field. If the body rises, it loses kinetic energy and gains potential energy. If the initial kinetic energy is not sufficient, the body will be unable to cross the barrier. But in the event that the initial kinetic energy is enough, the body may be able to surmount it and even have sufficient kinetic energy left to enable it to continue its movement. Similarly, the electric potential behaves like a barrier to the charged particles. It allows the particles to surmount it whenever the kinetic energy is great enough. The process of fabricating a p-n junction begins with an n-type or p-type doped semiconductor, into which the opposite type of impurity is introduced. To understand how this structure works and what physical processes take place in it, a didactic model is used. The model consists of a p semiconductor perfectly matched to an n semiconductor. The p semiconductor has a much higher hole concentration than the n semiconductor. Therefore, holes from the p region will diffuse into the n region. Similarly, electrons from the n region will diffuse into the p region. The diffusion of electrons and holes creates a region depleted of free charge particles, leaving behind the ionized impurities from which these charge particles come. Thus, a region of positive ionized impurities and a region of negative ionized impurities appear in the p-n junction. This special distribution of charges creates an electric field. The electric potential associated with these fields acts as a barrier that prevents the displacement of the electrons and holes. Equilibrium is reached when the diffusion current equals the drift current. The potential barrier is an obstacle for the diffusion current in the device. It is possible to reduce the height of this potential barrier by the application of an external voltage. This increases the electric current. By applying an external voltage from a battery, the height of the potential barrier in the junction is modified. If a positive voltage drop is applied between the p and n regions, the barrier height is reduced. A reduced barrier cannot prevent electrons and holes from diffusing across the structure. An electric current appears in the junction due to the diffusion mechanism. Under these conditions, the p-n junction is said to operate under a forward bias.